So in this video, we will be talking about left and right limits. So in the last video, we talked about limits, and so today we'll be formally defining the differences between a left and a right limit. So let's take a look at an example. So let's say I have the graph of a function f of x. So this right here, this is the left side of the graph, and here is the right side of the graph. So if I were to ask you, what is the limit as x approaches 2 from the left of f of x? So from the left, that's what the minus sign in the exponent denotes. So to find this, I'm going to approach 2 from the left. So I have the left over here. So I'm going to go from the left and just follow this function until I get to 2. So when that happens, I see that I approach a value of 4. So this is going to be 4. Okay, so now what is the limit as x approaches 2 from the right? So that's what the plus sign in the exponent means. Well, that means that I'm going to approach 2 from the right of the graph. So here's the right. So I'm going to just follow this function until I get to 2, and I see that there is a value of 6. So what if I were to ask you, what is the limit as x approaches 2? Well, as we can see, this function isn't approaching the same value from the left and the right. And so that means that the left-hand limit and the right-hand limit are not equal to each other. So when that happens, the limit does not exist. And so we use D and E to represent that. Now, what if I were to ask you, what is f of 2? So that would be, what is the value when x is equal to 2? So you need to know that an open circle means an undefined value. So that means that the function does not exist there. But if I look up here at 6, I see I have a closed circle. And so that means the function does exist there. So a closed value means the function value. So anytime you see a closed dot, that means that's the function value. So f of 2 is actually 6. So we've taken a look at a graphical approach. So now let's take a look at a numerical approach. So let's say we are given the limit as x approaches 0 from the right of the absolute value of x divided by x. So we are given a right-hand limit, and so whenever we're getting a right-hand limit, that means that we're going to choose values that are greater. So we're going to choose values that are greater than 0. So plugging some values in that are greater than 0, so 0.1. So we know that the absolute value of 0.1 is 0.1, divided by 0.1 is just going to be 1. Then if we do 0.01, well, that's just going to be 0.01 divided by 0.01. And so that's going to be positive 1. Now, when we get to 0, we get an undefined value because there's 0 in the denominator. Now, what if we are given the limit as x approaches 0 from the left of the absolute value of x divided by x? Well, left-hand limits means we're going to choose values that are smaller than 0. And so I'm going to choose a value such as like negative 0.1. So the absolute value of negative 0.1 divided by 0.1 is going to be negative 1 because the negative 0.1 in the numerator turns into a positive. If I plug in 0.01, I'm going to get negative 1 again. And then when I plug in 0, I again get an undefined value. So now let's recap all we've learned. So left-hand limits are the values as we approach them for the left. And so numerically, that means we're going to be choosing smaller values. Right-hand limits approach from the right. So this means we're going to be choosing values that are greater. And if the right-hand limit equals the left-hand limit, that means that the limit exists. However, if the right-hand limit does not equal the left-hand limit, the limit does not exist. So in future videos, we'll use this idea to develop continuity. Thank you, and I hope that was helpful.